Hello, in this short video we are going to investigate the following A+ level problem on the topic of trigonometry. If ln of sine x over 2 equals a, then the expression ln of 3 minus 4 cosine x plus cosine 2x is equal to. Pause the video at this point and give it a try to see which one of the following options is the correct answer to the problem. Okay, because this piece of information is given to us and this is wanted, so somehow I have to relate this expression to sine of x over 2. Let us see what we can do. Okay, the first thing that I want to do is to use one of the formulas for cosine 2x. This is cosine of 2 times an angle, so I will use one of the versions of the double angle formula for cosine. So let me write that version I'm going to use. I'm going to use this formula. Cosine 2x is equal to 2 cosine x squared minus 1. So I will start with my question mark and I would write it as ln of 3 minus 4 cosine x plus 2 cosine x squared minus 1. And now what happens? This 3 and minus 1 becomes 2. And then here I have 4 and 2. So I can factor a 2 out. So let me write it in 2 steps. So it becomes ln of, if you don't mind, let me write 2 cosine x squared first and minus 4 cosine x second. And then 3 minus 1 is plus 2. But now I factor a 2 out. So it becomes 2 times cosine x squared minus 2 cosine x and then plus 1. But hopefully you recognize the squaring pattern here, yes? So what I can do, I can write it as ln of 2 multiplied by cosine x minus 1 to the power of 2. Why is that? Because the first one squared is cosine x squared. 2 times the first one times the second one is the middle term, and the second one squared is this one. But now this is a product. We know that ln has this property that ln of a times b, if a and b are positive, can be written as ln of a plus ln of b. We also know that if a is positive, ln of a to power p can be written as p times ln of a. So for the second relation, it is crucial that a is positive, okay? And of course, for the first one, it's also important that a and b are positive because otherwise ln of a or ln of b are not defined. So what I will do, I will use this formula to write this ln in a separate form, okay? So it becomes ln of the first one plus ln of the second one. Okay? But be careful here. I want to use this formula to move these 2 to the back. But be careful because cosine x is maximally 1. Cosine x minus 1 is negative. So this formula will not apply. But you know that the second power, in the second power, I can write it as ln of 2 plus ln. I can write it as 1 minus cosine x to power 2 because this even power will allow me to write cosine x minus 1 to the power of 2 the same as 1 minus cosine x to the power of 2. Now this is guaranteed that this is positive because cosine is maximally 1. Yes, and this problem guarantees you that this x is a value for which this is defined, okay? So here we don't have any problems because if I want to make x, so you see 1 minus cosine x could in principle be 0 and this will cause the problem because ln of 0 is still not defined. But that is not a problem because cosine x becomes equal to 1. It means that x is a multiple, an even multiple of pi. But when I put it here, sine of n pi is 0 and ln of 0 is not defined. So this means that when they tell us that ln of sine x over 2 is equal to a, they are also guaranteeing that x is a number for which this ln is defined. So this means that I am really on the safe side. X is not equal to 2n pi, so it is guaranteed that this number is positive. So now I can move it to the back of the log. Yes, so what happens? So this becomes ln of 2 plus 2 ln of 1 minus cosine x. But now I want to connect, as I told you in the beginning, I want to connect this expression somehow to this expression, which we haven't done yet. There is another alternative for the formula of the double angle for cosine. Let me write it here for you as well. So cosine 2x is equal to 1 minus 2 sine x squared. So if I move 2 sine x squared to the left, it becomes positive. Yes, and I move cosine 2x to the right, it becomes negative. So I will get this formula. But this formula is valid for all choices of x, including x being replaced by x over 2. So then it means that this becomes 2 sine x over 2 to the power of 2 equals to 1 minus cosine of 2 times x over 2, which is exactly x. And that is exactly the expression that you see here. So I will continue like this. So it becomes ln of 2 plus 2 ln, and then I have 1 minus cosine x, which is 2 sine x over 2 to power 2. Yes? Now I will open this one up as well. So ln of 2, I copy and paste 2. I open a pair of brackets. This product can now be written as the sum of ln's, ln of 2 plus ln of sine x over 2 to power 2. I will also continue as before, so I move this 2 to the back of the log, so this becomes ln of 2 plus 2, ln of 2 plus 2, ln of sine of x over 2. But this expression is exactly your a. Yes, it is given to be a. So what I will do, I will continue. So this becomes ln of 2. I multiply 2 inside, so it becomes 2 ln of 2, and then plus 4 ln of sine x over 2. So this becomes 3 ln of 2 plus 4a. And that is the correct answer to this problem. So 3 ln of 2 plus 4a. So 3 ln of 2 plus 4a. So option C is the correct answer to the problem. I hope that the video was useful for you. Until the next video, be safe and goodbye. Thank you.